Yeah, no problem. So this is the least important slide, I think, of the whole deck. Just my background is I'm one of the co-founders of a company called 40 North Security. Basically, I do offensive security work for almost all of my career. I started as an IT systems admin and then moved into security. I like to think that I use a developer in a very loose terms where basically I like to write code until it doesn't error out on me anymore. At least gets past that, and I can deal with warnings. But I've just worked on various different projects. So what's this workshop about? Well, number one is going to be WMI. Can it be repurposed for offensive use? And hint, that answer is, fortunately, yes. So what can we do purely with WMI? Like, how can we use it to accomplish different tasks? We're going to work through that. I'm going to talk about a tool called Wmi Implant, and then we're going to discuss what defenses there are and how we can try to circumvent some of them. So a little bit of housekeeping before we get going. I'm going to assume that everyone has a laptop with a Windows 10 virtual machine, or you can buddy up with someone and check it out and look at the code that they're running if you want to. Or like I said, if you don't mind running code on your corporate laptop, by all means, go ahead and do that. If you have administrative rights locally, that will be easiest to do most of what we're going to talk about. Not everything requires admin rights when we're working locally on our system. But if you were to do this in a corporate environment and you're trying to do stuff remotely, you will need to have administrative rights, basically to do almost anything. And ideally, we're going to be comfortable with the command line. So this was, again, the link from the very first slide, which is, the link is kind of broken up terribly right here. But if you want to, again, need to download those files, you can go ahead and get them there. It's up and available on our website. And as you're working through this, try to feel free to build out these commands if you want. However, there is, like I said, I've mentioned, like an answer sheet, if you will, where it's kind of like a text file within that zip, which has pretty much all the commands that we're going to discuss and work through today already built out. So especially because we may be having to go through these labs a little bit quicker than I normally would, they're there if you just want to copy and paste and like get the answers and see them as they go. So let's talk about this. We're going to have roughly about like 20, 25 slides just to give background on WMI, what it is, how it's kind of structured, and then we'll get into, I promise, all the hands-on stuff. So first of all, what is WMI? Well, it stands for Windows Management Instrumentation. It's a service that's installed and enabled by default since Server 2000, so it's been quite some time that it's always there. And the big thing is it enables like system administrators or really anyone the ability to query local or remote systems for management purposes. Like we can gather a whole bunch of different types of data about the different systems that we're trying to enumerate and just learn about them. Like how much disk space do they have, what users are logged in, what applications are installed. There's a whole bunch of different things that you can use. And I think here's like the issue, I don't know if it's necessarily an issue, but more of like the tenet that I like to think of, and really most people I think in our industry accept, is that any legitimate administrative tool can be repurposed by an attacker for offensive use cases. So that, I think, rings true for WMI. So when we're interacting with WMI, like I mentioned, it is highly likely that we're going to need administrative permissions, except when we're doing stuff locally. So when you guys and gals are doing this on your workstations, if you have it or like a VM, you shouldn't need admin rights for everything. But when you're doing stuff on a remote system or targeting a remote system, you will. So there's two primary ways to interact with WMI. Wmi is one, although Microsoft has said that they are now deprecating that in favor of using PowerShell to interact with WMI. Although they've also been saying WMI itself will be deprecated for SIM, which WMI is still around, so we'll see when that happens. But Wmi is like kind of like the standard command line option that a lot of people might have used a lot to interact with WMI. So it might just look something like this, right? We've got, in this case, we're calling Wmi process call create. So basically, it's just trying to create a process right now. In this case, we're getting two different values as output. And the first one is, hey, we're creating task manager and it's starting it, and we're getting this value of 4044, which is the process ID of task manager that got started. The big thing here that we want, and pretty much everything you're going to be doing today, We want this return value of 0. Basically, that means that your call was successful, like whatever you did. If you get anything besides 0, something messed up, and trying to find what a non-zero return value means when being invoked over WMI on the documentation of MSDN is going to be a nightmare. So it's not a fun trip. So that's what we want to see. So that's what's happening right here. So we're just starting a process. The other option, though, like I mentioned, is PowerShell. So PowerShell does enable us to interact with WMI locally on our system or on a remote system that we're targeting. For the purpose of this, we're largely going to be using, I mean, these are like PowerShell version 2 commandlets, but there's a couple that we're going to talk that require Windows 10 Pro, Windows 10 Enterprise, or like Server 2016 and above, which we'll get to in a second. But for the sake of this workshop, we're going to be primarily leveraging PowerShell to do everything. So prior to using any of the PowerShell commandlets, though, when we are performing remote authentication or like enumeration of systems via WMI, we have to authenticate to that, right? Like I'd mentioned that it generally does require admin rights for anything that we're going to do. So what we need is to basically be able to authenticate leveraging PowerShell to a remote system. And we can do that by creating what's called a PS Credential Object. And so PS Credential Objects are basically what's passed to a remote system to say, hey, yeah, we have a username and password. This is who we want to authenticate as. And that's the only reason we need to do that, though, is if we're also not, so our current account is not an admin on that remote system that we're targeting. So we would need to authenticate as a separate user account. PS Credential Object is what lets us do that. And I'll show you again a code here in just a second. These objects can be created interactively or non-interactively. So the main commandlet that's going to get you what you want if you're operating in an interactive manner is going to be this get credential commandlet. And so that's just going to basically be like what pops up, almost like as if you were authenticating to a network drive. We're basically something like this. So hey, in this case, where is it? Creds is the variable, which is going to store our PS credential object. And so all we're doing is calling this get credential, storing it in creds. And then right here, this is what pops up. And so we can do this because this is interactive access. So we can interact with the desktop and enter our username and password. And it's going to store the PS credential right in that creds variable. Now, what if we're not operating in interactive access, right? That's because maybe we only have command line access or we're writing a script. Well, we can't obviously use get credential to have our screen pop up and just enter it. Well, there is, like I mentioned, also another way that we can do this. It's basically just like 2 extra lines of code, but we're going to do something called convert to secure string, which is going to be the commandlet that's essentially used to like store a password of store our password that we're using to authenticate with. And then we're creating the actual PS credential object here where we provide the domain, the username, and then the password output from this convert to secure string in order to create a PS credential object. So this is more, again, just kind of background right now. You won't have to do this today because you're going to be interacting pretty much locally, I would assume, with your Windows 10 virtual machine. But I wanted to be able to just give this background so that if in case you actually do go out and like test this in your environment, how you would authenticate to a remote system. This is basically what your code would look like. So I'm just at this top line just providing like the domain and the username of my account that I want to authenticate as. The second line is just whatever my password would be. And then we're providing that to this convert to secure string. We're specifying the variable, which is storing that clear text password is remote pass, and then we're providing the extra parameters as plain text and -force. And so that is creating this password. It's basically converting it into a secure string, go figure, storing it in this variable. And then finally, I'm creating that PS credential object where I'm providing the user account and the domain that I'm trying to authenticate as, and the secure string object. And that will be what actually creates a PS credential object, which is this variable, this remote credential. So that's what we need to provide our PowerShell commands that we're going to be running here in a second if we are authenticating remotely. let's talk about that now. And again, I know this is kind of abstract at the moment. We're going to get hands-on, and it'll be a lot more, hopefully make a lot more sense. But there's two main PowerShell commandlets we're going to be discussing today at least, when we're trying to interact with our systems over WMI. One of them is get WMI object, or I just usually say get Wmi object. And what this does is whatever our query is, it returns like objects related to it. So I love these definitions from MSDN, like returns an object containing a representation of a queried WMI class. So that's like incredibly abstract. Like what does that mean, right? So we're going to talk about it, and you're going to get hands-on with it in a second, but let's say you want to get like what are the processes running on a system. Well, we would use this get Wmi object commandlet, and it'll return back a whole bunch of objects. And basically every single process that's running is an object that's returned by this commandlet, and it has tons of different attributes, like what's the process ID, like what is the process's name, what's the parent process. Anything that's going to be associated with that process is returned as an attribute within this object, which we'll talk about and we'll look at manipulating. The other primary one that we're going to be using is Invoke Wmi Method. And this makes a little bit more sense. It runs a specified method of a WMI class. Well, when we're interacting with like WMI objects, or just like trying to run various, do certain things, like I said, if we're going to stick with processes, like we can easily enumerate what processes are running on a system, and that returns us objects. Well, if I want to create a process or like kill a process, one way that we would do so is to run a method of a class. And so there's a process called create where we can start processes locally or remotely, and we would do so using this PowerShell commandlet, this Invoke Wmi Method commandlet. To continue on, try to feel useful, or not useful, I'm trying to think of the right way to phrase this. I mess up my code all the time. Like, I don't know what I'm doing half the time. Like, Google's my best friend. So is interacting with the PowerShell Help content. I would say get comfortable like asking for help, like always researching stuff. I think one of the best skills that any of us, like IT people, not necessarily security, have is the ability to teach ourselves what we don't know or how to research and figure out what we don't know so we can get the right answer. So get comfortable like asking for help, because I'm constantly referencing man pages or MSDN, trying to figure out, okay, what's the right parameters I need to specify. So being able to do that, like especially if you haven't interacted with WMI before, is a useful skill set to build out, just to be able to how to answer your own questions. So here's just an example of like get help on this Invoke Wmi method. I mean, there's a lot here. There's a whole bunch of different examples that are shown that you can look at and try to work through, and it'll help also give you just what each parameter can do. So I would say check these out if you're ever running into issues, which is nice because it's just built right into your system. All right, so I think this is the last part before we start getting diving in, is how is WMI organized? Well, WMI leverages classes to group functionality of WMI into other logical classes. So if we want to access data on a remote system or a local system, we need to specify the WMI class that correlates to the data that we need. So there's a whole bunch of different classes. There's like computer hardware classes, classes that deal with like what applications are installed on a system, classes that contain information about the operating system itself, security descriptor classes. There's tons out there. There's process classes. So basically, in order to find out whatever information you are looking for or looking to gather, you need to know, okay, what class do I need to query to be able to return that information? Online, you can find Microsoft published and grouped similar WMI classes. So if you just do like a Google search for Win32 classes, you'll get pages like this where it says, hey, there's operating system classes, and that you can go into there and see, okay, what information is contained within this class. Like, you can use WMI to query what version of Windows 10 are you running, or of Windows, are you running. You can query, again, for like applications that are installed. So there's a whole bunch of different information that you can gather, but the big thing is knowing what class do you have to interact with in order to get that information. And the best grouping of that is really, honestly, going to probably be Microsoft's documentation in that case. Like I also mentioned, WMI classes do have methods which let you do something. And so that's when we would interact with like that Invoke Wmi Method commandlet, which you're all going to be doing shortly. Like if you want to create a process, there are classes that are built into Windows that enable you to do that. But like I mentioned, if you want to gather information like how much hard drive space is free on your hard drive, well, Win32 Logical Disk is going to be the class that you care about. That's one that would contain that info. If you want to create a process, well, there's a process class out there. What if you want to find computers with an active user? By that I mean like a computer system where someone is currently logged in. Win32 computer system is useful for that. Why is that useful? I remember I was on a test one time, and we were, it was like a pen test. It wasn't anything crazy, so we weren't trying to necessarily be stealthy. And we had either credentials or I forget what it was, something where we wanted to be able to log into a system and just remote desktop into it and like run an application or run a command. And we had probably like a couple thousand different computers that were joined to Active Directory that we could access. And I just started like sample remote desktoping into some of them. And every time I got in, there was always someone that said currently logged in that I have to kick off. Well, I didn't want to disrupt anyone from doing that. So eventually, after like 5 systems, I stopped being lazy and just trying to hopefully get lucky, and just wrote a quick like one-liner of PowerShell code where basically, because we had admin rights, I was querying all the systems in the domain using that Win32 computer system class to try to figure out, okay, if there is a system that doesn't have a user currently logged in, report that back to me. And after like, of course, 10 seconds, I had a pretty big listing, and so we could just choose and log into any of those systems at that point. So that was an example where being able to query every system basically that we could using WMI enabled us to pretty quickly figure out what system we could jump on and target. I have to also make sure to note that there are also SIM classes, and we're going to talk about them briefly in one small section during this workshop today. But these are also essentially like the WMI equivalent, and really almost like the future-proof way. So if you're going to start really diving into this, I highly always recommend diving into WMI, but I would also look into SIM classes as well, because that's what Microsoft says they're going to support and is WMI's eventual replacement. But I mean, granted, WMI is still there. But just worth looking into, so I wanted to make sure to call that out as well. All right, so now that we got through the background a little bit, let's start talking about WMI. So, talking about this, my buddy Casey Smith, whenever he learns like a new technology, his thing and the way that he likes to learn it is how do I make it run Mimikatz? Like it doesn't matter what language it is or like what bypass it is, like his hello world is make it run Mimikatz. I like to figure out like how can I introduce like basic, almost like rat functionality, leveraging different technologies. So that was the first thing that I did when trying to learn how to manipulate like WMI. So like I started off, okay, what are some of the basics, like some basic functionality I would expect in a rat that I would want it to have? Like, well, directory listings might be some of them. The ability to start and stop processes, what processes are currently running, can I view network connections, can I run shell commands? So these are all things that I kind of would like hope is like the bare bones basic functionality in something like a rat. What about some extras though, right? Well, I want to be able to upload or download files. I want to be able to possibly run PowerShell scripts, possibly in memory if possible, read file contents, create scheduled jobs, find active users. There's a whole bunch of different things. I want to be able to do all of that. Well, with WMI, you can accomplish like all of these things that we just discussed and that were on those few slides. So let's start looking at how we can actually do this with WMI. And I think it's fun to try to build out new capabilities. I get a lot of job-like satisfaction out of building stuff and actually seeing it being used. Really more so on my end, but like if other people like it, great. So let's do that. All right, let's talk directory listings with WMI. So when we're doing this, there are 2 different classes that are going to return the information that we need. So there's the Win32 Directory class, which, hot take, gives you a listing of all directories that for whatever location you're targeting on disk. And the sim data file class is going to be something that can also give you a listing of files. So if we want to get folders or files for a specific directory, though, what we need to do is create a filter. And what that filter is going to do is it's going to instruct PowerShell, or like the system really, on where do you want to get like your directory listing or file listing from, like what location on disk, what drive. So our code is going to look something similar to this, where we're just creating a variable called filter. We're specifying, hey, I want to look at the C drive. In this case, I just want to look at the C users directory. Like, give me everything that's within that directory. So if we want to do that, like, what's our overall command look like that will give us that information? This is basically it. The first thing that we do is create that filter. So we got our C drive, again, the directory. This can be any directory that you want. It clearly doesn't have to just be this directory. And in this case, I'm going to call Wmi Object. I'm going to specify the class, in this case, as Win32 Directory. I'm specifying the filter. And that should basically output then the various folders that are within that directory. And the same thing after that is, except we're just calling the sim data file class, and that should output the files that are in that specific directory. So that will be time for you all. I would say go ahead and open up a Windows command prompt or PowerShell. For this, you should not need admin rights since you're doing this just locally. But go ahead and try running these commands and see if you can get your output of your different directories or different files. I would say also try changing the filter so you can get used to trying to actually change like what directory you're actually getting this information from, and give it a shot. I'll try to put up a timer for about like 2 minutes just for time to let everyone go ahead and get through that. And if you have any questions, again, like now is a good time, or any time after this workshop as well, I'm happy to help answer questions. Oh, 1 sec. Now let's go. If you do copy and paste this from like the notes that came with the files, just be careful with some of these quotes because they might be like the pretty quotes and you're going to get like a PowerShell error because it's not like a regular quote. So they should output slightly different, but somewhat of the same, where like the Win32 directory is going to just only be showing like directories that are within that location. The sim data file should only really show files. If you're getting exactly the same, then that would be a little bit off, I would think. And I can either come check it or we can look at it after the workshop as well. Okay, okay, perfect. Yeah, no problem. All right, I'm going to go ahead and keep going just so we still have time to get through everything. Hopefully, oh no, can I do this? We should see something similar to this. And I'll show you an extra thing that we added here. But basically, this is just the Win32 directory. Every directory that's in like whatever folder you were looking for is an object. So you have different attributes associated with each folder. But these are all different folders that are in here. So like we have the name is just going to be like the path. Some of them are like hidden directories that you can't see. Here's also worth just something calling out. So I didn't talk about this TAC computer name command line parameter that you can specify. What that does is that's how you would actually perform this query against a remote system. So if we leave this off and just run the command that basically we showed back here, this is going to perform that query against your local system. If we are doing this and providing this TAC computer name command or parameter, that is going to run that query against either this IP address or the host name, whatever it is that you specify. Anyone have a guess why we don't have PS Credential Object up here? Partially, yeah. Well, so that would be how to change the context of the account that you're authenticating under. And in this case, this is running it under the context of the current user account that we're currently logged into. And because we're getting results, that must mean that the account this was ran under has admin access on that remote system. So we don't actually have to provide the PS credential object unless we are authenticating under a different user account. Here's a similar concept, basically almost very similar output for a SIM data file, except it would just be files in that case. So we're not actually getting any like directories. It just would be whatever file. So this might have been somewhat of a bad example because I only have one file here. But if anyone's like changed like the filter that you were searching for and like did your desktop or your downloads directory, assuming you had files and other directories in there, you should see that there were more results coming back to you. Any questions on this concept, or basically just being able to enumerate directories and files? Okay. And again, I know I'm kind of going a little fast through this, just trying to make sure we can get through everything within the time frame, but if you have questions after this workshop, don't hesitate to come up. Great, so we started talking about one of the basics that we care about, or at least I cared about, was performing directory listings. So let's talk about like processes, right? Because that's another interesting thing that I usually care about when I'm either trying to compromise a system or gather information about a system, is like what processes are running, like what's currently active on it. Well, WMI lets us very easily manipulate processes on our local system or on our remote system. And go figure, the class that is in charge of all of that is the Win32 process class. So that's going to be what exposes the functionality or capability of being able to take different actions on a system or to gather data about processes on a system. So when we start a process, basically all that we need to do to have is the path to the process or the executable that we want to run. Now, if the file is in the system's path, so let's say you want to start Notepad, you can just invoke it by its name. Otherwise, generally, it's going to require the full path to whatever application you're looking to get started. When we stop a process, we can do that via a couple different methods. You can do it by the process's name or the process ID. However, though, we're going to probably need a list of running processes first, especially if we want to go for killing a process via its process ID. Because if you get lucky enough to guess that, then you should win the lottery. So let's start with that requirement. Like, how do we actually get a list of running processes first? Well, it's super simple. We can call this get Wmi object and just specify the class, the Win32 underscore process class. We don't need to specify any filters, don't need to specify any parameters, don't need admin permissions again. This is going to dump information about all the processes that are currently running on your system. So give that a shot. This will be a whole probably 10-second query real quick. If you want to just run this commandlet, it probably looks disgusting if anyone's run it. Like, it's just a ton of information that's being brought back to your screen. Because remember, every single object is going to be, so every process is going to be shown on your Windows system, and every process that's returned with that query has a ton of different attributes. Like, there's just a lot there. So you probably saw something like this, where if we run that get Wmi object tag class Win32 underscore process, you have, and this is not at all even close, I don't think this is even close to being one full process. So we have different parameters, or excuse me, attributes. Like, we have a description of it. We have, if it was showing here, the executable path. Here's like the process ID. There's like parent process ID somewhere, which there you go, parent process ID. The name of the process. So there's a ton of different information that's returned whenever we just call just a get Wmi object with that Win32 process class. And that's great, we have all this, but it's really not usable, at least to me, immediately for the information I want. It's just a lot, right? So that output, like for an understatement, is just like a little bit verbose. So we can use PowerShell, though, to manipulate those objects and basically only return the data that we're interested in. So any of these attributes that are listed here, we can have, instead of returning all of this information, we can just have maybe one or two pieces of it, whatever that would be useful for the situation that we're currently in. And we can use PowerShell to manipulate those objects and get just that information instead of being overwhelmed with everything. So like we mentioned, the Get Wmi object commandlet returns an object for each running process. So let's just use PowerShell to interact and only select attributes of those objects we care about. So there's multiple ways to accomplish this. This is not the only way to do this with PowerShell, so I don't want you to think like this is just the way. This is one way that you can capture the data maybe that you care about. Since Get Wmi object returns objects as output, one way that we can manipulate that is pipe those results into another commandlet called for each object. And that lets us interact with each of those objects individually and get maybe only the specific pieces of information that we care about. The way that we do so is you're going to see within basically like the curly bracelets this symbol, like a $_ underscore, and that's basically the representation of a single object. So what are some attributes that we may care about? Well, maybe the process's name, right? Like if I want to get a process listing, then one of the things I probably want to get is like what are the names of the processes that are running. We can also get more than one attribute returned at a time. So we could have $ underscore dot name, comma, $ underscore dot whatever other attribute you care about. So maybe we also care about the process ID. So we can get that in there as well. So here's basically what our command would look like now. It's just same exact command as before, this Get Wmi object class Win32 process piped into this for each object. And then in this case, I just want to return just the process's name. So I would say go ahead and we'll give you all like 2 minutes, 3 minutes. Give that a shot. Try to get just the process names being output to you. And then maybe get the process ID of each process that you care about as well. Because we're going to try to figure out how to kill processes and start processes. And you probably want to have some of that information as well. So go ahead and give it a shot, just using just name, and try selecting whatever other attributes you may care about. And we'll sync up here in a minute. Hopefully, everyone was able to get something like this, where when basically we're calling our Get Wmi object, piping the output into our for each object commandlet, and in this case, I'm just printing out just the name. And so I'm able to get a list of the names of the processes that are running on my local system. If I did something like this, where we have $ underscore dot name, comma, $ underscore dot process ID, we are able to get, as you would probably guess, both the name and the process ID associated with each process that are running. So we'd have something similar to this, where we can, see the names and the process ID associated with each currently running process. Well, this obviously isn't like a very pretty format. Like you could pipe this into format table or format it in whatever way that you want to and make it look a lot nicer and more readable. But at least now we're able to select like specifically what attributes we care about out of each object in order to get the information that we need. Great, so now we should have the ability to enumerate running processes on our targeted system. Now, everything that we're doing here is local, I would assume. But again, remember, all we would need to do if we want to run this remotely on a system is just specify that tag computer name parameter, and it will perform this query, assuming we have obviously the permissions to do so on a remote system. So we can query remote systems running processes. Like, this is something that I do all the time prior to jumping on a system that I may want to target for whatever reason. The first thing I'm going to do is query, like, what processes are active on it. Like, is there someone currently logged in? And just to try to understand, like, what is running here? Like, is this like a sandbox and I'm seeing like Procmon and like everything, Process Explorer, like up and running with Wireshark? Is this like what AV's on it? Like, you can easily gather all of this data prior to actually compromising a system. You can do this all over WMI. So now that we have that information, let's talk about killing processes. So if we want to kill a process, it's done via a process ID or a process name. The big thing to note, though, is if we're killing a process by name, it's kind of like the shotgun approach. Like, we're going to kill every single process running on that system that has that name. So think about like Chrome. I forget how many processes Chrome gets up and running if you just have like one tab open. But if for whatever reason you're trying to kill an individual tab, you would really probably have to know the process ID of that tab. Otherwise, you're just going to kill everything Chrome related if we're killing a process by its name. The process ID is obviously the more targeted approach for what you may be trying to do. So in order to kill a process, we need to go back to what we did for when we were doing like directory listings and like file listings, right? So we're going to create a filter because we need to filter out of all the objects and everything currently on a system, what process do we want to kill and terminate? Well, we'll set a filter that either specifies a process's name or process ID. Additionally, the other thing that we're going to have to do is for the results that we get back, we're going to call a method on it, which will show how to do that. And specifically, we're going to call the terminate method. And that, as I'm sure you can guess, is what's going to be used to actually kill a process running on the system. So basically what we're going to do is we can use like Get Wmi Object with a filter to try to just capture the processes that we care about. We're going to pipe those results into a for each object and then call that terminate method to kill that process. So our code may look something like this. So here we have Get Wmi Object. We're specifying our class. We're specifying our filter is process ID equals, in this case, 6152. We're then piping that into for each object and then calling terminate. Now, do we actually have to do that this way because there really should only be one object coming back? Like, no. Again, there can be multiple ways that this can be coded. This is just one example. But this is where we're going to be interacting likely with more than one process, is this next command, where we're basically searching for any process that has the name of chrome.exe, piping all of those objects into this for each object loop, and then calling terminate on that to kill those processes. So now's your all's turn to go ahead and work through this. What I would recommend is start like Calc or Notepad a bunch of different times on your system. Why don't you go ahead and try to enumerate the process ID of those processes, and then go ahead and try to kill them. And you can try it out killing it via its process ID, or killing all of them by its name, like notepad.exe. So I'll give everyone, let's do like 2.5, 3 minutes to go ahead and give that a shot. And yeah, I'd say just start up like your sacrificial process, whatever you want to dominate, like Notepad, and test this out. We got 2 minutes from now. Oh yeah, Explorer is always good. LSASS is always good. Yeah. I think it should, because these are basically like management commands. I think it should also work, I believe, in constrained language mode as well. But yeah, it should all work in it. All right, let's go ahead and keep on going. So hopefully everyone's able to see something like this. So in this case, I already know whatever the process ID, whatever it is that I'm trying to terminate. But in this case, I'm, again, calling get Wmi object, find my filter of whatever the process ID that I'm targeting, piping that into for each object and calling the terminate method on it, and I'm getting some output right here. And the big thing we want, which we talked about earlier, is this return value to be 0. So if you especially, feel free to try from like run PowerShell in a non-admin context, try to target like LSASS, try to kill it, and you should see that there will be a non-zero return value because it's going to fail. But this is what should happen if it works correctly and you have the permissions to do so. Here's an example of doing it by targeting via a process's name. So in this case, it's chrome.exe we're targeting, and I have at least 2, there may have been more down here in the screenshot, different instances of seeing like, hey, I've returned values of 0. So I know that I had at least 2 processes running that were running as chrome.exe on that system. Like I said, there may have been more just because Chrome likes to start up a whole ton of them. But that's what it hopefully should look like. We should be able to do this, get a return value of 0, and have killed those processes. So we talked about process listings. We talked about killing processes. Well, let's start about starting a process, right? So starting a process follows a similar format, but it's going to be a different commandlet. Like we've been using, get Wmi object the whole time so far. But now we want to call a method. And when we're talking about process creation, though, it's worth noting that I like to think of this as what I call like a blind process creation. So what does that mean? Let's say you can start a process like ipconfig on a remote system if you want, and you'll get a 0 return code and like the process ID of whatever that process ipconfig started with. What you don't get are the results. You don't get anything back from it when you're targeting a remote system. If you target your local system, you'll probably see a command prompt pop up real quick and then go away. And that's what I call starting a process like blind process creation, because it does start, it gets up and running, but you don't actually get any output. It's just nothing is returned. It's just starting the process and that's it. So it's worth noting that if you were trying to get output, you need to do so in a different way. And we'll talk about solving that challenge later on. But just standard, if you want to start like a command prompt or whatever you want to ping, doesn't matter. We're going to be using this Invoke Wmi Method commandlet to do so. And we're going to call again on the Win32 underscore process class. The method name that we're going to call is create, because we're trying to create a process. And then we have to specify the path of the process that we want to create. Now again, if we're just trying to spawn like Notepad or something in like the system's path, all we need to do is just provide Notepad, because the system will obviously resolve that. However, if it's not in the system's path, what we need to do is specify the full path to whatever executable it is that we're trying to run. So in this case, if we're trying to start a process, it may just look something like this. All we're doing is calling Invoke Wmi Method. We're specifying the Win32 process class. The name of the method we're trying to run, in this case, is called create. And then our argument list is what is the application that we want to install, or not install, run. In this case, just Notepad, but otherwise, remember, you would have to provide like the full path to it. So I'll give everyone a minute or so. Why don't you give it a shot, starting Notepad, Calc, whatever your creativity says that you want to start. let's keep going. I actually don't have a screenshot, I guess, of this, but hopefully everyone was able to, when they ran a command like this, or whatever application you were looking to run, you got that return code of 0 along with the process ID of whatever process you created. And it's pretty much that simple. Like, creating a process is really easy to do so. It's just running this and specifying what it is that we're trying to start. Before we move on, does anyone have any questions or comments or anything you want to talk about with, like, directory listings, file listings, starting a process, stopping a process, or creating them? Or, excuse me, process listing? Okay. All right, due to time, we're going to talk about Wmi persistence, but we're not going to do a quick lab on this. Plus, you'd probably be having to battle a little bit of AV just because of the faster way by using Powershell to install this. But it's worth discussing because this is, I use as an offensive security practitioner, Wmi Based Persistence all of the time, assuming I have the permissions to do so. So I want to make sure to talk about it and how it works. So if we're going to create persistence via Wmi, we have to create what's called a permanent Wmi event subscriber. And so each Wmi event subscriber has 3 parts that, like, create this. It is an event filter, an event consumer, and a filter to consumer binding. So what are those? Well, what's an event filter? Well, so think of it like as events happen on your computer, or things happen, like Wmi events are created. So, like, does the minute change on, like, your clock? That's an event. Is a USB drive plugged in? That's an event that you can filter on. There's just a massive amount of events that are always happening on your system. So an event filter allows us to, of all the events that are currently happening, let's filter out and only return the results about things that I care about. And so you can make that be whatever it is that you care about. Like, maybe you want to have an event filter that is only fired when it's 3 p.m. each day. You can do that. There's, again, tons of different things that you can do. So yeah, so that's basically essentially what an event filter is. An event consumer is something that takes an action or does something. So there's 5 different event consumers that are out there right now. There's a log file event consumer, ActiveScript event consumer, NC event log consumer, SMTP event log consumer, and this last one's one of the interesting ones, as the command line event consumer. The command line event consumer, when invoked, lets you run a command line command, so you can execute code. If you only play with, if you want to do more and dive into this, I would also highly recommend checking out ActiveScript event consumers. Because rather, instead of just running a command line command, we can run various code, like JavaScript, VBA, anything that you want. So it's worth checking out. So great, we talked about an event filter and event consumer. So the filter to consumer binding, like, what is that? Well, that's what pairs the two together, and it kind of marries them, where it says, hey, if this specific filter is triggered, so 3 p.m. each day, pair it with this consumer, which takes this specific action. So that's what combines the two and makes them linked together, essentially. And so now, but with the 3 of these, the event consumer, the filter, and the filter to consumer binding, we have what we can use to build out Wmi Based Persistence. So how can we go about creating them? Well, Powershell is one way that we can very easily install Wmi Based Persistence. Matt Graber and that team built out a Powershell module for creating Wmi Based Persistence. So this is one way to do it. This is not the only way. You can obviously manually write this code out, but just for time's sake of this workshop, we're just leveraging that. So if we want to do Wmi Based Persistence with the payload, or with the script that does that within Powershell, how do we provide it, or how do we do that? Well, the first thing is we need to do is create a payload. So, like, what do we want to ultimately, like, be done? So, like, if you want to run a command line command or run your rat or whatever, you would specify that here. Otherwise, in this case, we're just spawning Notepad. We need to, just because of this persistence technique, the way Powershell's module works, we need to specify both admin level persistence and user level. User level doesn't matter as much because if we're admin, we're going to choose to install Wmi Based Persistence, but we have to specify it because it requires it. So in this case, we're just specifying that the user level persistence option is we basically want to create a registry run key and have it run whenever someone logs in. However, the admin level persistence is this elevated persistence option. In this case, we're going to say, hey, we want a permanent Wmi event subscription, which is basically these three things: the event filter, consumer, and the binding. It will generate the code for you that creates those. And we want that to run, in this case, daily at 3 p.m. So we can tell it every day, 3 p.m., I want our payload to be triggered. And finally, all we need to do is just generate, after we've run these three commands, we're going to take those outputs and create and run one more command, which will actually generate our script that will install persistence. So here's where we're just specifying everything, like the payload that we want to run, the elevated option, which is our Wmi event subscription, the user level one, and then it's going to output the scripts that we would use to install it. So this will actually, if you run it as an admin or run the installation script with administrative rights, it will install that Wmi based persistence. It will also give you a script that you can use to remove said persistence. So probably a good thing. So I would say try this for homework. Definitely worth playing out on a VM that you can just convert. But you'll be removing it anyways. But with Powersploit, the way it works, it'll probably get flagged. But after you see how it generates it, you can do different things with it. So like our output basically is going to look like this is what the script would look like. So at the very top here, this is base64 encoded, but this is where we're just having it run whatever our payload is. So it's going to decode that, and like that's our command or whatever. So in this case, maybe not in this case, but like in the previous example, that would be where it just starts Notepad. What it is doing here is this is where we're installing our Wmi based persistence. This is that code. This right here is the code for just creating basically a registry run key. So I'm actually just calling that out right here. So what's actually happening is here is where we are setting our event filter. So this is all PowerShell code that it's going to run. And that is going to filter on the time. Where is it? Somewhere right in here. Where it's basically going to filter for, 1500. There we go. So for 3 p.m. daily. The consumer is where we are specifying, in this case, a command line event consumer. We're calling it updater. And the command line command it's going to run is just going to be just calling PowerShell in a non-interactive manner. And that's because it's actually, in the back end, it's creating a malicious PowerShell profile, which automatically runs malicious PowerShell code. But when PowerShell.exe is run, it's going to be invoking our code that way. And then finally, we have our filter to consumer binding, where we're saying, hey, when this filter is hit, perform and run this command line event consumer, which is going to run our code. So this is good for an initial proof of concept, but like, what if we only want to install admin-based persistence, which we probably want to because we don't want a registry run key? Well, you can just remove the checks. Like, it's just easy PowerShell code, but leave the check for a role because you want to make sure you're still running as admin rights. Otherwise, it won't install. There are other modifications that you can make as well. So, like I said, this one does use a malicious PowerShell profile. What if you don't want to do that, right? Like, what if you don't want to trigger a PowerShell? We have a ton of different other options, right? Like, you can perform an app whitelisting bypass. You can have your rat, whatever you want, be dropped and invoke that. So it's really anything that you want to do. So like, you could change your code, like in this case, to do something like this. So we removed PowerShell. In this case, we're running squibbly2 and specifying like our malicious comm scriptlets located at this path. And that's basically everything that we would need in order to get that regsvr32 based bypass running. It's also worth noting, though, that depending what your payload is will depend how you get potentially a callback, assuming that's what you're trying to do. When we're using PowerShell, what will happen is you'll get your, unless say you have like a Cobalt Strike setup or like Metasploit, and you get your connection back to you. When we're running PowerShell, it's going to get the results back to you in the context of the user account you created that under, but in like a high integrity process, so like running an admin. If you do something like this, where we're doing like a bypass, in this case, I think you're actually going to get your callback as system. So it is worth noting and looking at and testing out like your persistence to see what you're going to get your callback as, to make sure like you can egress like your network boundary that you may be having to like operate within. It's just worth testing that out so you know, because I can't think of many network proxies that allow system accounts to go outbound. I hope there's not many, so just worth looking into. Has anyone ever played with ASR rules? Just curious. Do you like them? Do you have them like deployed or just tested with them? Yeah, I've only in my career had one client that's ever had ASR rules deployed. I love them. I think they're great. I think everyone should. They're free, but no one does. So let's talk about ASR rules though, right? Like what are they? Well, it's a technology built into Windows 10 that should say Pro and Enterprise and Server 2016. So it's already there. It's for free. Like you don't have to pay anything for it. And it stands for Attack Surface Reduction Rules. And these are like a series of rules that you can use to help try to restrict like commonly abused functionality within your domain. As of this morning when I checked, there are 16 different rules that are supported. So what are these rules? Like what do they do, right? Well, there's some basic stuff like block Office apps from making child processes. Like Word probably really shouldn't need to spawn PowerShell, right? Or like command. There really should be no reason for that. We can block untrusted processes running from a USB drive. We can block like JavaScript or VB script from launching downloaded content. We can potentially block like what we think are like obfuscated scripts. So like these are functionalities that like different attackers use, right? Well, there's also this one that's a kicker, which is kind of like, oh shit. There's this rule for block process creations originating from PSExec or WMI. Like, well, crap. Like that really kind of like dominated what we were talking about so far, right? Like because I have a strong interest if I'm trying to laterally move. I like to use WMI to start a process on a remote system. But this rule outright blocks it. Oops, uh-oh. I did something. So if someone had that rule enabled on their workstation and an attacker like me or you or whoever tried to start a process via WMI, this would pop up. This is what you would see. It would just say, hey, your IT admin like caused Windows Defender to block this. Doesn't say anything about being malicious, just says that like there's a visible pop-up that the end user is going to see on their system. And from our side, it's going to have something like a return code of something not 0 because it's going to be blocked. So this is not a good time from an attacker's perspective. Great time from a defender's perspective. Oh, I have a screenshot of it. So this is me just trying to start like Notepad on a system with that enabled. In this case, I have a return value of 2. So I'm pretty sure like I could probably spend a few hours and maybe find on MSDN saying like a return value of 2 equals to like the ASR rule. But eventually, just note, again, if it's not a return code of 0, your process creation failed for whatever reason. It just didn't work. So this is the cool thing, though. There's always a way around this, right? Microsoft allows us to remotely administer antivirus and like endpoint configurations, right? Like it makes it easy. That's for management. Like why? Of course we want to be able to do that. So we can though enumerate antivirus configs remotely. Like I can figure out like what is installed on the system. Are there exceptions in place? What rules are potentially enabled? Are ASR rules enabled? But even better, we can modify and change the properties of like an antivirus configuration on an endpoint inside an environment. I actually have like a couple different blog posts up on just enumerating AV configs and like modifying AV configs. And you can do this remotely too. You don't have to just do this locally on a system. So how can we do that? Like that might be useful to try to get around this problem, right? Well, there's 3 commandlets here that let us do that. The get MP preference commandlet is going to be what lets you enumerate your current antivirus configurations on your systems. Add MP preference appends rules to an existing configuration. Set MP preference like overwrites existing rules with whatever it is that you're trying to do. Now, If you're doing set MP preference, you may have to battle with like group policy if that's always being like continuously pushed down. So just know that. We can enumerate and do all of these things remotely. Well, these commandlets use sim. So we really briefly talked about sim earlier on. We used it to enumerate like files in a directory. So we use sim sessions to authenticate and basically gather this data on a remote system. If you're trying to gather this locally, you don't need to use sim. But when we're trying to do so remotely, we do. So sim sessions use WSMan for remote access, but they can also fall back to DCOM. And if we're going to try to gather this data and change systems, we have to create a sim session. And so to do so, we need to use these two commandlets. So what does that look like? Generally, in the environments that I'm in, WSMan is not enabled for workstations. I'm generally using DCOM if I'm trying to do this step. So in order to specify that, the first thing I'm doing is saying, hey, I want to create a new sim session, but one of the options is it has to use DCOM. So I'm specifying that in this variable. I'm still creating a PS credential object. So remember, we looked at creating those for when we're trying to interact remotely with the system. So that's what we're doing here. There's like our plain text password. Here's creating the PS credential object right here. And then finally, I want to create that sim session. So in order to do so, I'm calling new sim session. I'm specifying the computer like IP or host name that I want to target. I'm specifying the PS credential object, which was just created. And I'm specifying, hey, what extra options, like I only want to use DCOM, I'm specifying that right here. And assuming I don't get an error, this variable right here, sesh, whatever you want to say, is my sim session that I have established with whatever remote system that I'm targeting. So, like I mentioned, I generally go DCOM just because that's generally what's available. But like you said, you do need to create a PS credential object if you're running or need to authenticate under the context of a separate user account. If you are running as your current user account, you don't need to specify this credential object because it will just authenticate as you. So once we've created a sim session, it's just as simple as providing that session, so like that variable, to the commandlets to authenticate remotely to the system. So let's look at like gathering antivirus configurations from this system that we're targeting. So we're going to use get MP preference. So if you all want to give this a shot, now you don't have to do this top part because you're going to be targeting your local VM, but make sure you're running under the context of an admin process, and go ahead and try calling get MP preference. Again, you don't need to do the rest of this because you're just going against your local system. And you should hopefully start to see something like this being returned. So I'll give everyone a minute. What you may not have, though, and it's worth noting, depending upon your version of Windows that you're running, is you may not have these top ones, this attack surface reduction. And if that's the case, I would say partner up with someone that does so you can test it out and see what it looks like, because you may not have the version of Windows that Windows 10 that supports it, because it requires Pro or Enterprise. But I'll give everyone just a second here. You're basically just, again, running this get MP preference. The big thing in this case is I'm seeing that I have a version of Windows that supports attack surface reduction rules. When I have a 1 here for actions, that means that it's enabled and like enforcing basically. And what happens here, this like GUID basically stands for the rule, the specific ASR rule that is being enabled and enforced on a workstation. You can have more than one rule. If we had more than one rule in this case, it would just be comma-separated GUIDs that were outputted right there. So thankfully, depending upon your perspective, you can enable or disable rule enforcement on a workstation, assuming you have permissions to do so. Remember, this goes back to the whole tenet of, like, I firmly believe any administrative tool can be repurposed, fortunately or unfortunately, for like offensive use cases. So what we can do is use like the set MP preference commandlet to both enforce or disable ASR rules. And to do that, we would basically look something like this. We would tell the rule ID and whether we want it to be enabled or disabled on that workstation. So how do you get these long, crazy GUIDs, right? Well, they're all documented online. Like you can go just do like a Google search for like list of Windows ASR rules, and it's all documented on MSDN. So that actually does have like what the rule is and what the associated GUID is with that. So what I want everyone to do, assuming you have the Windows or version of Windows that'll support it, is go ahead and try to enable that rule to block WMI from starting a process. Try to start a process, and you should see that that's blocked. Then go ahead and disable that rule and try to start the process again, and you should see that that is now, you can now do so. So I know this is kind of big, or small, excuse me, there's a lot of text here. I have all the commands here. I think, again, the answer sheet that like came with the slides should have this. So I'd say go ahead and give it a shot. And if you, like I said, you can Google online and get this exact GUID, so you can just copy and paste this. But I'll give everyone about like 2 or 3 minutes, because it's a little bit longer, to go ahead and test this out and try to see what it looks like. Yeah, they did. Yeah, that was probably one of the harder environments that we had to do a test against. Oh yeah, like it definitely can. Yep. Yeah, it's work to have to deploy that and make sure like your environment is set up to be able to do it. But like, it's just like application whitelisting. No one wants to do it. It's a lot of work to do it. But I always ask every customer, and it's not many that's ever deployed it, like, do you regret doing it? And I've never had one say that they regret doing it, just because it immediately ups the barrier for like an attacker. Say that again? I believe it would. So it's not under like defense if you went and looked at it like in the settings, but I think it's just built into the OS, like core OS. It's the OS that enforces it. So I believe you should be able to use like a separate AV if you're not using Defender and still enforce these rules. And actually, now I think about it, the customer that I tested that did have these rules enabled had a different AV solution. Yeah, for this one, that GUID is specifically just for process creations via PSExec or WMI. But like, how far back do we go? There's like, I mean, these are only a subset. This is like 5 of the rules. So 5 of the rules total of the 16 that are available. And like all of this is built into, like I said, Windows 10 Pro, Enterprise, and like Server 2016 and up. So you can just enable them for free. Yeah. Yes, I will throw it at the end of it again. I'm sorry I would do it right now, but it's at the very beginning of the slides. But yeah, I'll get them up there for you. Let's see if I can find a video of it real quick. Oh, sorry, everyone. I'm just trying to find a video. Not that one. All right, let me move this over. Hey, it worked. All right, so here's an example of what it hopefully would look like for everyone. I can't see. Okay. So basically, I'm just calling get MP preference. Oh, I'm sorry, I thought that was maximized. I'm using this, and this is oh, no. Okay. Showing that, hey, we do have ASR rules enabled. Go back just a little bit. And I'm doing this remotely. But we can see we do have ASR rules enabled, and that's the specific GUID that it's using. So because that rule is enabled, I'm going to try to create a process. In this case, we'll see what it is. Maybe it's just Notepad. Yeah, Notepad. And it failed. And we see I got that pop-up saying that, hey, that action was blocked. And there's a return value of 2. So now I want to change that, though, right? I want to change it so that I can disable that ASR rule on that system. And so I'm going to basically use the set MP preference commandlet to do so. So I have to paste the GUID, which I do, and then I basically have to set like the attack surface reduction, I think it's like action, and set that to be disabled so that that rule is no longer enforced on that system. And when we run, and I have to specify the sim session, assuming I'm doing this remotely, and that should have disabled it. So now if I do another AV, like enumerate the AV configs on that system, I can see that that rule is no longer being enforced. So now if I were to try to go ahead and run and create a process with Wmi, then I can do that, and it should be enabled and work now. So ultimately, if you have admin access, like I'm preaching to the choir, you can do anything regardless of what is in the environment. So you got to obviously protect that admin access. All right, yeah, go for it. Yep. Yeah, and that's similar to, and I think what we're, the last little bit that we're going to talk about now, has anyone ever played with like Device Guard, or now they call it Windows Defender Application Control? It's like a mouthful. I love it. It's a free, basically app whitelisting solution. It's like App Locker 2.0. It's way better than it, because you can do a lot more enforcement with it. And similar concept though, like you can deploy it in audit mode and see like what's running inside your environment, and then you can choose to enforce like a set of rules or not. Not to talk too much about it, but yeah, it's like Device Guard is like all like digital signature based, so you basically make a rule set on like who do you trust that digitally signs code. So like Google, Microsoft potentially, and you can do it at like the root certificate, like all the way down, as far down the chain as you want to go. And that obviously can change like where your trust lies and if you have to update your policies often, but you can use WDAC to do a lot of like interesting defensive stuff, and it makes life incredibly hard as an attacker. Yeah. Off the top of my head, I'm not sure. I don't believe so. But yeah, I'm not certain, so I don't want to give the wrong answer. All right, so let's talk like Wmi implant now, and this speaks like the last section, and like Device Guard. And so all of this basically started because, and like my dive into Wmi is like I wanted to know how to basically attack like a Device Guard protected system, because like gone is the days with this where you can just drop custom compiled code. It's going to be outright blocked. Because it's, unless you stole like the digital signature of your target, or like a digital certificate so you can sign your own code and make it work, you're not going to be, it will just be outright blocked with WDAC. So this is a similar question. Anyone here has deployed app whitelisting? Like anything at all? Yeah, I pretty much, usually anytime I give like a talk, I like to ask that question. It's usually only like maybe one person in the crowd. It's a lot of work. But I always also ask, like I was saying, the same people, if anyone's just deployed it, regretted it. I've never had a person say yes, because it's an incredible amount of work, obviously, but it just, like the telemetry that you can get on your systems, like it instantly makes an attacker like light everything up, because if they're, until they can figure out how to operate in your system or inside your domain, they're going to be incredibly noisy. So there's a whole ton of different solutions out there that offer like that capability, both free and commercial. But in my mind, like Device Guard is like the epitome of what like a strong app whitelisting software solution is. It enforces not only like executables, but it also does like DLLs, it does kernel level. So you can, I've bricked my Windows systems multiple times because I've accidentally untrusted a specific driver that Windows then tries to boot and just boot loops forever because it doesn't trust it, and it wasn't for. Oh yeah, yeah. I've done this plenty of times. So where I just like I come back like 10 minutes later, like my computer's not booted. So then it's a long process of like undoing your change. But if you got physical access, you're king. So anyways, though, like I wanted to figure out how do I attack, like from an attacker's perspective, device guard protected systems, because I want to know, like I'm assuming I'm going to go up against that technology at some point, although with that thought process, I never have yet. I've never in the wild seen a customer like deploy device guard, but I wanted to have a capability that existed in case I did. So I started looking into that. And basically what I was trying to think of is like device guard, again, app whitelisting locks everything down. So I wanted to know like what's a technology that exists that is most likely to be trusted and running on like a Windows system that I could potentially abuse. And that's where Wmi came in. Like I wanted to figure out like how could I use that for offensive purposes to whatever it is that I'm doing. So I made this tool called Wmi Implant, which you're all gonna, if you want to be able to play with in a second. It was developed purely in PowerShell, specifically in constrained language mode. Has anyone ever like dealt with constrained language mode? It sucks. It's like not a lot of fun to write code. It's basically supposed to be, I don't know if you ever remember like the original like Windows RT tablet, like back in the day. That constrained language mode was like made for that. Like that was where it's first born to like run on there. And it's basically used, it's supposed to be like an administrative only mode of PowerShell. So like you can't do anything on it. Like if you try to do like what's the square root of 9, it's gonna tell you it's blocked because it's like it does too much potential dangerous stuff in the background. So it's a lot of fun to code in, I'll tell you that. So I had to write a tool though that worked in purely constrained language mode because when you deploy device guard, it automatically enrolls constrained language mode and forces that on the system because it wouldn't make sense to have app whitelisting like enforce, but then you have full version of PowerShell that you can just run like Mimikatz or whatever you want in and get your code running. So they have to enforce that. But I also thought like Wmi could be used to target these systems. So that's what like really forced me to dive and figure out like how does Wmi work, like what can we do with it? And so that's what I built, is I use Wmi as the mechanism to trigger actions. So like what we've been doing, like we can start a process on a system all over Wmi. It's like the C2 channel for like transferring data. And it's also being able to be used for data storage, which we'll talk about. So yeah, it's written purely in constrained language mode. Very unfortunately, that caused very many annoyances and frustrations with PowerShell, but it makes sense. So I wanted to have basically the ability to store data in like a temporary buffer area, right? And the reason that I wanted to do that is I wanted to solve the whole blind process creation problem. Remember we talked about where like if I want to start a process on a system, I can't get the output. So what if I want to get the output of ipconfig though? Well, I have to have like a temporary area that I can store like the output, maybe like pipette data into there with PowerShell and then retrieve it in order to get that output and solve that problem. And we'll talk about like the methodology for doing that in a second. And so what I was originally doing when I wrote this is I was leveraging a systems registry. And so I was basically taking the output from commands that I was wanted output from, storing it in that registry, because I can very easily from an attacker's or from anyone's perspective, I can query a remote systems registry. I can retrieve those results. So if I can run a command, store it in the registry, and then just remotely query that key, whatever key it is, for its value, I can get the output. And that's all can be done over Wmi. So there's a lot of pros to it. Like the nice thing is it's not limited in size. I can shove a lot of data in there. But there's a lot of tools out there that like look for registry modifications, that like parse it and do different things. So it was going to potentially be a little noisy. So this actually led to me having a conversation with a previous coworker of mine, Matt Dunwoody, talking about APT29. I believe they're the Russian group. And what these guys were doing, or this group was doing, is they were creating custom Wmi classes, adding properties to a class, and then storing like whatever data that they care about as the value to that property. So I was like, that's actually pretty nifty. Like, that's a good idea. Let's see if we can recreate that. And Matt Graber actually published a proof of concept code in like a white paper that did exactly this, where basically we're just creating like a management class. We're going to create the class name, in this case called Win32 evil class, and then calling this put method. You can think of what's the put method is basically save. Like it saves whatever you just changed to the system. And in this case, they're creating a property called evil property with the value, this is not the malware you're looking for, and we're calling put on that again. So that should create the class and create a property within that class on whatever system I'm targeting. So I want to figure out, how can I do this? Well, that introduced a problem, though. So I'm sorry if this is a little hard to see, but what I'm doing up here is we're creating that class under this root simv2 namespace, calling the Win32 evil class as the name, calling put, and it took. So I can create a class within this constrained language mode as an admin, and that worked easily. However, when I went to create a property, I'm trying to add evil property, this is not the malware you're looking for, and I got this stupid message, which I got so familiar with, where it's basically saying method invocation is supported only on core types of this language mode, which basically is the easy, nice way of saying, like, hey, this doesn't work in constrained language mode. It's outright blocked. So that was really weird to me, right? Like, I thought if, like, on the hierarchy of things, if anything would have been blocked, like at the top level class, it would have been blocked, but it's not the case. I can create a class, but I just can't create a property for that Wmi class. So I didn't think that it would work. I wouldn't be able to use Wmi to store data, but then I had one more idea that I wanted to try. What if instead of like creating a new class and then creating a property in it, what if I enumerate every single class that's on the system already? What if I enumerate every single property of all classes, and I look for classes that are like a string data type that I can write to, that can be modified in constrained language mode, that won't blue screen the box? Like, that would be interesting to me. So I modified a script that I found online that does exactly that. Like, you can, if you really want to, go check it out. But it enumerates all properties. It captures all, enumerates all classes, enumerates all properties within every class, and then looks for properties that are writable strings. And then it will just display those results out to me. So this returned like a mixed bag of results. Like, some of the results only allowed like a fixed length of data. So for example, one modifiable string property is your system's host name. And you can modify that over Wmi. But like, you run into like your max host name limit, and then it just eventually won't work anymore. So it could work for very small sizes of data, but like, I didn't know how big of data I wanted to be able to transfer. Other properties error when modifying the value, and this is when I got probably the most annoying error, which was generic failure. Like, I don't know what that means. I don't even know how to Google that because I didn't even get an error code. Microsoft was just saying generic failure, so that was great. It did identify a class, though, that I'd never seen before, and it was this Win32 OS recovery configuration class. Like, I'd never heard of this. And this is the class, though, that's used to specify like the type of data that's collected and where it's saved to when your system blue screens and when Windows crashes. So I never would have thought of this. Here's just like a representation of it. We're calling Get Wmi Object on it. It has different properties like debug file path, name, setting ID. And there's a lot more that's just not shown when we output the results here. But it's a class. And specifically, the debug file path property has a writable property that is a string data type. And what that is that's the location where when your system blue screens and it crashes, that's where Windows writes the memory dump to on disk. So it's a file path. So like right here, it's saying it's going to write to system root and then memory dump. Well, that was interesting, but I'm like, this should only accept a file path, right? Like, because it has to write this to a file. And I'm also assuming that it's limited in length, right? Like whatever the maximum like file length is on Windows. So that's what it looks like, but trust and verify, right? So here's our check now. What we're doing is we're verifying we're in constrained language mode. I'm getting a representation of that Win32 recovery configuration class and storing it in this variable A. I'm modifying the property debug file path to all your base are belong to us, and then calling that put method, and it took. So I wanted to verify, like, did this take, like, what's it doing now? So I'm getting another instance of that class in this B variable, and we look, I can see the debug file path property actually did change now to all your base are belong to us. It's no longer a file path. I would have no idea what would happen if my computer decided to blue screen at that moment, where it would go, but I have a writable string property. So that was awesome because I can now write arbitrary strings to property. It's not just like a file path, right? Like, there's no validation on the data that's being placed there. The Wmi implant also uses an encoder, like if I want to encode like binary data. So the encoder that's built into it will also work because it's just basically comma-separated numbers. The only issue to test, though, is like how much data can this hold? And so that's what I wanted to figure out next. So basically, I'm capturing that current class again. I'm setting all your base are belong to us basically times 1,000,000, calling put, and that took again. And so I want to see how big that was, and I outputted that to disk, to a text file, and I was able to store like 57.2 megabytes of data, which, like, if anyone's, like, I'm happy if I get like a megabyte. So like 57 is a ton. I can just shove whatever I want in there. And that gave me everything that I needed. I wanted to try to stress test it to see like how much data can I actually put in there, and I actually got to the point where it was half a gig, and at that point I just stopped because there wasn't really a point in seeing it anymore. But it gives us everything we need. I have a writable string property. It's writable in constrained language mode. It's not fixed in length, and it doesn't blue screen the box when I change that. So now I have the ability to leverage Wmi to store data in Wmi and remotely query it. And so this is basically the methodology that this tool uses for any time I want to get output. Is the very first thing that happens is I query like a remote system's debug file path property to get the original value. I then encode the command that I want to run on that system. I use Wmi to create a process on that system and have PowerShell run that command. So let's say it's just the ipconfig. I believe if you all look at the answer sheet, ipconfig is the command that's listed in there for what to run. And it then runs that command, captures the results, encodes it, and stores it back in that debug file path property on that system that we're targeting. Eventually, my attacker system is continuously querying that system that I'm targeting like every 10 seconds, 15 seconds, whatever you want it to be, and it will look for when does that property value change, because when that property value changes, then I'm assuming the command is done running, and the results are there. So at that point, it notices that the property changes, or the value changes, it decodes those results, displays it to the console, and then set the debug file path property back to the original value to like keep it at what it was. This is purposefully like sleeping every 10 seconds and then querying for the value. But I mean, this whole process, if there was no sleep, would take place in like a quarter of a second. Like, it's incredibly fast. So that's basically what is happening here. We're querying for the value, we're running PowerShell, we're storing the results on that system, and then we are retrieving the value and displaying that on my attacker system so I can get those output. So this is how I'm solving like that blind process creation, by storing the output in an encoded format on the victim's or targeted system's Wmi property, and then I can just remotely retrieve that and get the results. So I'm going to go through these last few slides really quickly, and then I'll give time for like questions, or if you want to demo and like play using this methodology, it's all in your notes if you can do it. And I'll let you go because I know I'm going to be holding up lunch. So it's a lot to ingest, but like, again, all we're doing is getting the original value, and to do that, it's just basically this command. We're calling Get Wmi Object on the system, getting specifically the debug file path property, and we're keeping that so that we can return it to the original value. We're spawning PowerShell to have it on that victim system, and it's going to run whatever command we told it to do. So whether ipconfig, ping, notepad, msbuild, Registry 32, whatever it is you want to run, it can do. And so, yeah, that's basically what I just said. It's going to run that command and then store the output of that. It's going to re-encode that and then store it in that debug file path property so that we can remotely retrieve that. And at the very end, we are retrieving the results right here. We're outputting the results of what it is, and then we are setting that debug file path back to the original value. And we can remotely like retrieve it and save it just like that. And then that will actually return it back to its original contents and original value. So ultimately, here is what it looks like. I'll try to walk through this relatively quickly. This is, again, where we first retrieve that debug file path property. In this case, I'm running ipconfig whack-all, and I'm basically going to be running that command, storing it in this output variable. Then here's where I'm setting the debug file path property on that remote system to the value of my ipconfig command, and then saving that. And so here's where I'm basically just calling this PowerShell command. I'm then running Win32 process to start that PowerShell command on that remote system, basically giving it a second or two to run. Then after that, I'm remotely retrieving from my attacking system the contents of that remote system's Win32 OS recovery configuration class, outputting the contents of that debug file path property, setting it back to the original value, and then saving it so that we can, again, leave it like as it was. And like I said, this whole process only really takes like a half a second or as fast as you can type your commands. So I'm going to talk real quickly at the very end because I know we have 5 minutes and I don't want to hold everyone up. But I'll be here if you have questions and you want to look through any commands. Obviously, we can happy to talk to it and work through it with you. So everything that we just did, like all of these commands, everything that you did today so far, getting directory listings, process listings, starting processes, killing processes, like I wanted to teach it with what's actually happening. Like this is how you would actually do it. Like that's the foundational commands that you would do if you tried to do this manually. I created this tool that I mentioned, Wmi Implant, that does everything for you in the background. So you basically tell it what system you want to target, what process ID or process name you want to kill, and then it transparently just does all of that. Same thing with like starting processes. It can run PowerShell scripts in memory on a remote system without ever dropping anything to disk. And that uses that C2 methodology where it like stores the PowerShell script in that Wmi property, retrieves it, gets the results, sets it back, and then we can remotely retrieve the results. So you can do a whole bunch of different things with this, and it automates all of those steps for you. Like I said, it basically, let's just go through like some super quick commands. Like we can read a file's contents. So like if you see password.txt on a desktop, we can retrieve that all over Wmi, basically using like that C2 methodology. You can upload or download files. One thing we didn't cover, but that's super useful, I think I have a screenshot somewhere, is right here. Is you can use Windows' built-in search indexer, where I can remotely search for files on a remote system, and it'll return the full paths to it. So like I can do a wildcard search, and this is using Wmi Implant to do it, but it'll do a search for like paths with like wildcards on the ends, and it's going to tell me, hey, it'll index and search the entire file system and let me know exactly where those files would be on disk. So like in this case, I'm just searching for a Wmi Implant on this system remotely, and here's like a couple instances of the file paths where it's located at. So as you can imagine, like you could do this to search for stdid files. I mean, anything that you can think of. It'll search for like file extension or by name, and it can wildcard everything. That's mostly it. Like you can run commands. You can do blind process creation, or you can have commands run where you actually get the output. Same concept with PowerShell. You can run a PowerShell script on a system and retrieve the results. I got 3 minutes left, so that's actually good timing. And that's largely, the main thing was like, I wanted to teach everyone like how you can do this manually so you understand what's happening in the background if you use a tool like this or likely other tools that leverage Wmi. But then this is an option that can enable you to automate everything. With that said, I'm basically at time. I know we had to go a little fast to start a little late and then ending about now. And again, don't want to hold you up for lunch, but I hope this was useful, trying to see like Wmi can be used in a lot of different ways to do different things. Again, it ultimately comes down to, I think, any admin tool can be repurposed, fortunately or unfortunately. And this is just a built-in technology that you can use to do what you want. So if you have questions, let me know. Feel free to come up and ask, talk during lunch. Otherwise, thanks everyone for coming. Appreciate it.